Okay, a parallelogram. Well, first of all, 8.2, properties of parallelograms. A parallelogram is a quadrilateral, which is a four-sided figure. A quadrilateral with both pairs of opposite sides that are parallel. So let's zoom in here. A quadrilateral. So let's write quadrilateral with both pair of opposite sides that are parallel. So let's draw that in there. Then we've got this side is parallel to this side, and this side is parallel to this side. AB is parallel to CD, and that's what I've written over here. Okay, so that's what a parallelogram is. Let's learn some stuff about them then. Theorem 8.3 says this: if a quadrilateral is a parallelogram. So if we start off and at the very beginning we have a parallelogram, then its opposite sides are congruent. Okay, so all it says is this. I already know that these things are parallel, so I guess we'll write those in green here. I know that this side's parallel to this side. I know that this side is parallel to this side. Okay, I already know that. It says if I know this. So if this AB is parallel to CD and BC is parallel to AD, then I know that opposite sides are congruent. So I'll write that in red for your learning convenience. Then I know that AB is congruent to CD and AD is congruent to BC. So double congruence marks. In fact, I'm gonna erase these parallel things here because I don't really want those. We're saying if that, then I've got these congruence marks right here. And okay? So that's all it says. If I've got a parallelogram, then I know that I've got opposite congruent sides. Okay, Theorem 8.4. It only gets more fun as we go further down the page. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So once again, if I start with this thing, if I've got parallelness, parallelogram, then I've got opposite angles are congruent. So this angle is congruent to this angle, A is congruent to C, and B is congruent to D. If I've got a parallelogram, I've got opposite angles are congruent. I think that probably looking at that, you'd probably believe that. Next, Theorem 8.5 as we move down the worksheet of fun. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. This is an important one. This is important. Consecutive angles are supplementary. So, first of all, consecutive angles are right next to each other. Okay, so A and B, these are consecutive, and I'm not sure if I can, let me see if I can write that small on this thing. Let's see. Consecutive. These are consecutive. Those are consecutive angles, A and B. Okay, now they're clearly not equal, right? They're clearly not equal. But what they are is supplementary. Remember, supplementary, this means add up, the angles add up to 180. 180 degrees. So here's how I'm going to represent this. In this parallelogram, if I call the angle D, let's call that x degrees. And I want to call angle C y degrees. Then I know this. Let's try a different color. How about purple? Then I know this, that x plus y, because they're consecutive, which means right next to each other, those things add up to 180 degrees. 180 degrees, okay? They're supplementary, add up to 180, and that's all it says. If I've got a parallelogram, so once again, if this stuff, if I've got that, parallelogram, and all this says is that I've got these things in parallel, blah, 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 blah. Let's be careful here. Okay, if I've got a parallelogram, then I know that x plus y equals 180, or consecutive angles are supplementary. Okay, Theorem 8.6, and the last theorem I promise for this section is that if a quadrilateral is a parallelogram, once again, we have this parallel stuff over here. So this is if this. Okay, if I've got that, and its diagonals bisect each other. Remember this word diagonals from back in the first section? Diagonals are when we connect two vertices, right? Then the diagonals bisect. And remember that bisect means cut in half. Okay, so let's draw in vertices. Let's use the line tool here. Yeah, okay, here, let's see if it'll work. Let's draw, oh, that didn't work. Okay, undo. Let's see. Okay, this is turning into a failure. I want the line. Okay, let's see. I want line AC. This is not going well. Well, imagine that that's actually drawn to line AC, and then I'll actually just draw on the other one. And then I've got BD. Okay. What this says, in fact, what this theorem says is that the diagonals bisect each other. Okay. So if I draw this, and then let's say that these meet at point M. Okay. So it says this, that BM and MD, the doctor, are congruent to each other. Once again, BM and MD are congruent. It also says that AC and MC are congruent to each other. Okay, so it says these two things. Let's write them down. AM equals MC, like MC Hammer, but a little bit different. And that BM equals MD, like a doctor, but a little bit different. Okay, so those two segments are equal. The diagonals bisect each other. Okay, now let's move down and let's try some examples here. So now I'm going to move this. Oh my, okay, so I'm going to have to fix that. Problem fixed. Okay, now let's move down and over here to find the value of x and y in this example. Wow, look at all the space I left you. Okay. We're going to have to use some theorems in this one. I know how much you love theorems, but I think that most of them will be pretty clear. The first one, remember that first let's draw these lines, and these are parallelograms. Okay, everything that we're using today are parallelograms. And I have a rule. Let's find x first. So let's find x. Okay, let's find x. I have a rule that says opposite sides are congruent, or the opposite side lengths are equal. Okay, so I have a rule that says x plus 4 is equal to 12. Okay, so let's write that. X plus 4 equals 12. Let's subtract 4 from both sides, and I get down to x equals 8. And that's it. I found x. Okay, now let's find y. Alright. Well, y and 65, these are opposite angles, right? These are opposite. So if they're opposite of each other, we have a theorem that says that opposite angles are what? Hopefully you just said congruent. So if we want to find y, well, that's pretty simple. Y and 65 are equal. So y equals 65 degrees, because let's try a little zoom action here, because these are opposite. Okay, these are opposite angles. Okay, let's move on to another example. In this example, once again, I've got opposite side. I've got a parallelogram, right? So let's real quick, we'll draw these little lines in here so we know that we've got a parallelogram. Anybody to be confused? Okay, I want to find x and y again. Okay, so let's find x and y, and I have a rule once again that tells me that the diagonals, right? So the diagonals like AC and BD, those bisect each other. Bisect means cut in half, which means that that 5y minus 13 and 2y are equal, congruent, and 16 and 2x plus 4 are equal. Okay, so let's set up an equation. Let's find x. Find x, okay? Well, 2x plus 4 equals 16 because this side is congruent to this side. This segment is congruent to this segment, okay? So 16 equals 2x plus 4. Let's solve this thing for x then. Minus 4, I get 12 equals 2x. Divide by 2, I get x equals 6. Okay? 6. Cool. Now let's move on and find y. Let's do it in a different color. Oh, how about light blue? We haven't done that this chapter yet. Let's find y. Okay. Well, I know that 5y minus 13 and 2y, those things are equal or congruent because the diagonals bisect each other. So BD is bisected. So 5y, I'm going to run out of space here. So let me zoom in and see how far I can zoom here. 5y minus 13 equals 2y. So 5y minus 13 equals 2y. Let's subtract 5y from both sides. Minus 5y. And I get negative 13 equals negative 3y. Dividing both sides by negative 3. Ooh, I get a nasty fraction. Let's see. I get y equals, that's going to change to a positive. 13 divided by 3, you'll probably get it quicker than me, is going to be 4 1/3, or about 4.3. Okay, 4.3. Okay, here we go. Next example. Find angles 1, 2. Oh, we find angle 3 while we're at it. I know I've got a parallelogram here, so I'm going to draw these little lines in here. That oh my. Okay, let's get rid of that. Okay, sorry about that. I want to draw on these little, parallel indicators here. Okay, now this one is going to be a little bit tricky for me to kind of convey without doing a lot of pointing and gesturing. But kind of, if you need to pause, rewind, I will try and explain it as best as I can. So here we go. BC is parallel to AD. All right, so I've got AD parallel to BC. Let's worry about angle 1 first. Okay. I know from way back in geometry A that the angle's 35. That angle is congruent to angle 1 because they're alternate interior angles. Remember, if we have parallel lines, if we extend the parallel lines, we've got a transversal. And if we think way back to geometry A, those are congruent. So the measure of angle 1 equals 35. Okay? Measure of angle, so let's do some stuff here to help. Measure of angle 1 is 35. Now let's find 2. Angle 2 is congruent to not congruent to 35, but it is congruent to 47. It is congruent to 47. Okay, so if those two things are congruent, because once again, they're alternate interior angles. BD is a transversal to two parallel lines. Okay, so measure of angle 2 must be 47. Okay, and we've got one more. We want to find angle 3, so let me do a little bit of cleanup. You might have room here to write it, but I'm going to zoom in, and I know that angle 2 is 47. Okay, and I want to find angle 3. I want to find angle 3. Well, I know that all the angles in this triangle add up to 180. Okay, so here's what I would do if I were you, and I'm not, but this is what I recommend, is that 35 plus 47 plus angle 3, measure of angle 3, equals 180. Okay, if I combine like terms, I get 35 plus 47 is going to be 70 plus 12 is 82, plus the measure of angle 3 equals 180. And solving for angle 3, I subtract 82. I get down to the measure of angle 3 equals 98 degrees. Not a very good band, but 98 degrees nonetheless. So we've kind of gone through and we've found all those angles. Hey, think about this, while you're, bored and can't think of anything else to think about. What's another way we could have found angle 3 if we kind of used 82? Check that out. Okay, and that's it for section 8.2. We're doing good, right around 15 minutes, so once again, I try and kind of respect your time and get as much info in as short a time as possible. And hopefully that helps. We've kind of learned a bunch of theorems, we've applied a bunch of theorems, and I would like you to do this last example here. I want you to find x on your own. Okay, so you're going to have to figure out which theorem. Once again, we know we've got a parallelogram. You should find x on your own. I don't think it'll take you too long. So good luck, and we'll see you tomorrow in class.